Alright guys, in this video we're going to continue where we left off in the previous video where we had just gotten finished with talking about all of the properties of logarithms and how they related to the properties of exponents. In this part of the section, and in this video, we're going to talk about how to do two things related to those properties. We'll first talk about how to expand logarithms, and the idea behind that is to write the logarithms as separate as possible using all of those properties. We'll then go the reverse, and we'll look at how to condense logarithms using those properties. In other words, how can we write them as a single logarithm? The condensing part is the more important part, because it's going to be more useful when we get to solving in the next section. But in order to understand condensing logarithms, we really have to understand how to expand them first. Okay, so in order to expand each of these logarithms, we're going to use the properties of logarithms that we talked about in the previous video. And if possible, we're going to go ahead and simplify. That was something we really didn't do when we first were talking about the properties of the logarithms. So in this first example, we've got log base 4 of 16 multiplied by AHK, or 16 multiplied by HK. And so remember, multiplication gets separated using addition. So what we could do is we could rewrite this as log base 4 of 16 plus log base 4 of h plus log base 4 of k. And then we also need to look to see if we can simplify anywhere. For example, log base 4 of 16 is asking the question, 4 to what power is 16? Well, 4 to the power of 2 is 16. So we're going to replace log base 4 of 16 with the number 2. If you weren't sure, then just use change of base formula, type it into your calculator, and you could simplify that way instead. The rest of it has variables, so we're not going to be able to go ahead and simplify, so we'll go ahead and write that separately as log base 4 of h plus log base 4 of k, at which point we'd be done. Next, for number 2, we've got log base 2 of 8x squared. Once again, there's multiplication in between the 8 and the x squared, so let's just start by separating that using addition. So log base 2 of 8 plus log base 2 of x squared. For the first expression, log base 2 of 8 is asking 2 to what power is 8. The answer to that would be 3. 2 cubed is 8. Again, use a calculator if you're not sure. Next, for log base 2 of x squared, what we can do with exponents, remember, is we can write them in front of the logarithm using multiplication. So that would be a plus 2 log base 2 of x. And then here would be our final answer. Next, for number 3, we've got log base 5 of x over 25. Remember that division can be broken apart using subtraction, so we can rewrite that as log base 5 of x minus log base 5 of 25. Of those, the second can be simplified. Log base 5 of 25 is asking 5 to what power is 25. The answer to that is 2. And then we'll just copy down the log base 5 of x minus in front of the 2, and then there would be our final answer. So let's do a few more examples of expanding, and then we can look at condensing. So in this next example, we've got log base 4 of the square root of 16y to the 8th. So let's do this first. Let's go ahead and just simplify that square root of 16y to the 8th. So the square root of 16 is 4, and y to the 8th, you'll take your exponent and divide by the index. 8 divided by 2 is 4. So that would become log base 4 of 4y to the 4th. At which point, we now have multiplication in between our values in the argument. So we'll go ahead and separate that first using addition. So that would become log base 4 of 4 plus log base 4 of y to the 4th. The first can be simplified, log base 4 of 4. 4 to the first power is 4, so we'll write that as a 1. Next, we'll take the exponent that is on y and move it to the front of our logarithm. So that's plus 4 multiplied by log base 4 of y. And at that point, we would be done. Keep in mind, we cannot simplify that any further. And if you're wondering that on number 2 as well, we cannot take 1 plus 4 and call that 5. Remember that order of operations says that we have to do multiplication before addition. So the 4 that's in front of log base 4 of y is being multiplied, so we cannot add it together with the 1. So make sure that you leave those separate. All right, for number 5, we've got the natural log of the cube root of 4x minus 5 over 8. So let's first separate this using subtraction. So we've got division. Remember, division gets separated using subtraction. So we'll call that the natural log of the cube root of 4x minus 5 minus the natural log of 8. Next, we'll use our rational exponent property from Unit 7 to rewrite our cube root as a power of 1/3. So that would be the natural log of 4x minus 5 to the power of 1/3 minus the natural log of 8. We can then go ahead and take our exponent and move it in front of our natural log. So that would be 1/3 multiplied by the natural log of 4x minus 5 minus the natural log of 8. And while natural log of 8 is just going to be a number, it is going to be a decimal, which cannot be simplified or not be rounded off. And so that's why we're not going to be able to simplify that. And in fact, actually at this point, we would be done, and this is how you would leave your final answer. Finally, for number 6, we've got log base 3 of 4x to the 4th multiplied by y to the 5th. So again, we've got multiplication in between each of our terms. So let's start by separating number 6 using the power or the product property and calling it log base 3 of 4 plus log base 3 of x to the 4th plus log base 3 of y to the 5th. At this point, we're going to take each of our exponents, which are on our variables, and move them to the front of each of those logarithms and write it as log base 3 of 4 plus 4 multiplied by log base 3 of x plus 5 multiplied by log base 3 of y. And at this point, we just look to see if there's anything we can do to simplify. Log base 3 of 4 is not going to be a whole number, so we'll leave that as it is. And actually, at that point, we are done. Here's our final answer. And so really, as far as expanding goes, the real reason that we want to look at expanding is that we actually want to go the reverse direction. And we want to look at what's called condensing a logarithm. And in condensing a logarithm, we're trying to write the logarithm as a single logarithm. And in fact, that's how you know you're done, is that when you're condensing, as soon as you have it written as a single logarithm, you know that you're done. So let's go ahead and look at these. And remember, now we're going to be using all those rules in reverse. In other words, when you see addition, that's going to become multiplication. And where you see subtraction, that's going to become division. And so when we write these together, we're going to take each of our arguments and multiply here. So 7 multiplied by x. And then we're going to divide by the argument for our last. So that would be dividing by y. Notice that log base 2 just stays the same. You don't put the 2 or the log or anything like that separately. You just combine them together. And then the arguments you write using those operations. And here would be your condensed logarithm. So number 2, we've got 5 log base x of m minus 2 log base x of n. So the first thing we're going to do is we're going to take those numbers in front and we're going to move them back into the logarithm as exponents. Remember, we were going the reverse direction for expanding. For condensing, we're now kind of putting them back together. So we're going to have log base x of m to the power of 5 minus log base x of n to the power of 2. Next, we'll recognize that this is subtraction. Remember that subtraction becomes division when we put the logarithms together. So we're going to write it as a single logarithm, log base x. And then we're going to divide the arguments, so m to the 5th divided by n to the 2nd. And here would be our final answer. All right. On number 3, we've got a little bit more work to do. So first, we're going to start kind of the same way. We're just going to take our 2 and move it in as the exponent for our logarithm. So that's going to be log base 4 of 8x squared, and make sure that you have the 8x in parentheses being squared. And then plus log base 4 of 2y minus log base 4 of 2x. Next, we'll go ahead and look at our operations now that we've taken care of the exponents. In our operations, notice our addition and subtraction. So addition, we're going to multiply those arguments together. Subtraction, we're going to divide the arguments with that. And so let's go ahead and put those together. So we're going to copy down our log just once now. We'll go ahead and multiply together the 8x to the power of 2 and the 2y. And then we'll divide that by the 2x and make sure that you're putting it in order from left to right. That's super important. And now we just want to try to simplify as much as possible. Starting with 2 and 2, obviously 2 divided by 2, we can simplify those out. And then before we simplify anything further, let's go ahead and write out what 8x would be squared. So obviously 8 squared would be 64. X squared would just be x squared. Then copy down the y that came after it, all still over x for right now. Because then we can simplify actually one last time, x squared over x. We can cancel this x out with one of these x's. So now for our final answer, we'll have log base 4 of 64 multiplied by x multiplied by y. All right, I think we've got 3 more examples to look at, and that'll be it for this section. So number 4, let's start by moving our numbers that are in front of the logarithms back into the logarithms as the exponents. So that will be log base 10, which I'm just going to write as the common log, log of x to the power of 1/4, plus, and again, I'm going to write it as the common log, and then we're going to have that as 2x minus 3, and our exponent is now a 5. So now we've got addition, which we can put together using multiplication. So that will be log of x to the power of 1/4 multiplied by 2x minus 3 to the power of 5. Now keep in mind that that power of 1/4 can actually be written as a radical, and so let's go ahead and write that out. Remember that a power of 1/4 is the same as the 4th root of x multiplied by 2x minus 3 to the 5th power, and here would be our final answer. All right. For number 5, we've got 5 multiplied by the natural log of x plus 2 minus 3 multiplied by the natural log of 5x. So once again, let's go ahead and move our numbers, which were in front, in as our exponents. So that would become the natural log of x plus 2 to the power of 5 minus the natural log of 5x to the power of 3. Notice that anytime you move an exponent into the logarithm, that anything that was in the argument needs to go in parentheses unless it's just a single number or a single variable. But if it's a quantity, make sure it goes inside parentheses. Next, we'll go ahead and use this subtraction to put them together. And remember that subtraction is division. So the natural log of x plus 2 to the 5th power divided by 5x to the 3rd power. Now, if it's an expression like x plus 2 where it's got more than one term, you really don't need to write that out. But for something like the denominator where you've got 5x to the power of 3, it's usually pretty easy to go ahead and write that out and take 5 to the power of 3, which is 125, and then x to the power of 3, which is x cubed. So if it's a rather large expression like x plus 2 to the 5th power and would take some time to multiply it out, just go ahead and leave it. No need to expand that. But if it's a single term like 5x to the power of 3, then it really isn't too hard to go ahead and distribute that exponent throughout, and in which case we'll go ahead and use that to simplify. All right, for this last example, for number 6, we've got 1/2 multiplied by log base 3 of x plus log base 3 of 2x minus 9, and there was a parentheses that got chopped off. I'll go ahead and put that back in now. It really would not have mattered in the long run of this problem. So before we take care of the 1/2, let's kind of use order of operations to just focus on that group that's inside of our brackets. Notice that inside of those brackets we have addition, so we're going to go ahead and put that together using multiplication. So that's going to be log base 3 of x multiplied by, in parentheses, 2x minus 9. Keep in mind all of this does need to stay in those brackets until we deal with that 1/2 that's in front. And before we deal with that 1/2, I'm going to go ahead and distribute everything inside of the log. Let's call that log base 3 of 2x squared minus 9x. It's up to you, though, however you want to write that. I'm going to go ahead and, like I said, distribute it, but if you wanted to leave it separately, you could. Next, we're going to take that 1/2 and we are going to move it in as the exponent for our logarithm. So that will be log base 3 of 2x squared minus 9x to the power of 1/2. And we've seen this at least once before. Remember that that power of 1/2 then becomes a radical because the denominator is a 2. That makes it a square root. And so log base 3 of the square root of 2x squared minus 9x is what that would become. And here is our final answer. All right, guys, so that is it for our properties of logarithms. At least right now, it's just some properties and it's just some practice using those properties. The real kind of use for this is going to be in the next section when we begin to talk about how to solve exponential and logarithmic equations. And especially when we get to logarithmic equations, we'll see why it's going to be useful to be able to condense logarithms in particular, which is what we were working on at the end of this section. Until then, have a good rest of your day.